This episode covers buffers and electrolyte. Regarding buffers, almost everything you need to know for this class is on this first slide. The next few slides explains how buffers work. It is not required for this class. So let's look at the key points about buffers. A buffer solution is a solution that can resist pH change. Normally, when you add a little bit of acid to our solution, the pH will decrease. When you add a little bit of base into a solution, the pH of the solution will increase. However, a buffer solution has some unique components in it that can resist pH change. You add a little bit of acid, pH will not change too much. You add a little bit of base, pH will not change too much. Of course, any buffer will have its capacity. If you keep adding a lot of acid or bases, the pH eventually will change. But with certain capacity, a buffer will resist the pH change. So that's the function of a buffer solution. It resists the change of pH when a small amount of acid or base is added into the solution. So what is it? Why can it resist the change of pH? The reason it can resist pH change is because inside a buffer, you have a mixture of a weak acid and its conjugate base. Of course, again, we are not going to explain why a mixture of a weak acid and its conjugate base can resist pH change. We do not have to know that for this class. So remember, a buffer system, we have a weak acid and its conjugate base in the solution. So in this class, you are required to know this, and they will give you certain mixtures inside the solution, and they will ask you if this mixture will make the solution a buffer or not. So here is the practice. The aqueous solution of which of the following mixtures can potentially function as a buffer solution? All right, we are given 1, 2, 3 different kinds of mixtures. We need to identify if this mixture potentially can be a buffer system. Well, what do we need to do? We need to figure out if the mixture includes a weak acid and its conjugate base. So let's look at the first one together. Well, we have an acid, carbonic acid, and we know it is a weak acid. Again, how do we know that? Because it is not one of the 7 strong acids. That's a weak acid. Do we have its conjugate base? Sodium bicarbonate. That's a salt. That's not its conjugate base. Wait a minute. We are talking about the aqueous solution. We all know that when a salt is dissolved in water, they do not stay as salts. Each salt formula will dissociate into individual ions. So when you dissolve sodium bicarbonate in water, it will break up. It will break up to stay as sodium ion and bicarbonate ion. So if you dissolve sodium bicarbonate in the solution, in the water solution, you're going to have a lot of these ions. If that is the case, can you see that in the solution we have weak acid, which is carbonic acid here, and we also have its conjugate base. Bicarbonate ion is the conjugate base of carbonic acid. So we do in this mixture, if we dissolve this mixture in the solution, we do have a mixture of a weak acid and its conjugate base. So this is potentially a buffer solution. The second one, we do have an acid, HCl. Well, based on our discussion on the first group, sodium chloride, when you dissolve in water, you are going to have sodium ion and chloride ions. Yep, we do have a conical base. Chloride is the conical base of HCl. That looks like a mix, a buffer solution, an acid and its conical base. Well, this is not a buffer solution. It cannot function as a buffer solution because HCl is a strong acid. You must have a weak acid and it's a conjugate base. So for a mixture like this, when you see HCl right away, the answer is a no. Well, the third one, let's look at the third one together. Two compounds, each one of them is a salt, sodium dihydrogen phosphate, sodium hydrogen phosphate. Looks like both of them are salts. Well, let's dig into it. Sodium dihydrogen phosphate, if you dissolve it in water, you have a mixture of sodium ions and dihydrogen phosphate. Sodium hydrogen phosphate, if you dissolve it in water, you have sodium ions and hydrogen phosphate. Although all of these are ions, however, this pair does make a weak acid and its conjugate base. This hydrogen phosphate ion is the conjugate base of dihydrogen phosphate ion. The two differ by 1 proton. If you add a proton to this one, you're going to get the dihydrogen phosphate. This is a buffer system. Make sense to you? So mixture number 1, mixture number 3 are potentially buffer solutions. Mixture number 2 is a no. All right, so for questions like this, let me summarize it again for you. To answer questions like this, look at the two components in the mixture. If it is a salt molecule, break them into ions and try to see in the whole mixture if you have a weak acid and its conjugate base. If you do have that, that is potentially a buffer system. Here is a practice for you. Practice, identify possible buffer solutions. So you have solutions of different mixtures. All right, I will ask you to pause the videos now and complete them, and unpause the video, check the answer key. Here is the answer key. I hope you got them right. Let's move on. Okay, this explains why buffer solutions can resist pH change. Again, you do not have to worry anything about this for this class. Same thing, it is explaining why adding base would not affect the pH of a buffer. Adding an acid would not affect the pH of a buffer. Again, not required for this class. Henderson-Hasselbalch equation, an equation used to calculate the pH of a buffer solution, not required for this class. You are going to see one question using this in the lab for this class. We are going to discuss that when we perform that lab. So again, this section would not be tested or quizzed. Don't worry, this is not required. Electrolyte. Electrolytes is a topic you need to know. Acids, bases, salts, when they're dissolved in water, they produce ions. Be it ionization or dissociation, they all have ions in its water solution. Therefore, ions are charged particles. Therefore, they can conduct electricity. So, substance whose aqueous solution conducts electricity, we call that substance an electrolyte. For the same reason, if a substance whose aqueous solution does not conduct electricity, it is called a non-electrolyte. Couple examples for non-electrolyte. Solutions of table sugar, glucose. These are solutions of molecular compounds. These molecular compounds are not like the areneous acids. Areneous acids are molecular compounds. However, when you dissolve them in water, they ionize to produce ions. They release protons into the solution. These molecular compounds do not have the ability to release protons to be ionized. So most of our molecular compounds, when they're dissolved in water, they are non-electrolytes. They do not ionize. Well, here is a picture showing you they do not conduct electricity. They place a bulb inside the circuit, and you have two electrodes dipped into the solution. They apply the voltage. If the solution conducts electricity, the light bulb will be lit up. Now, it doesn't because it is a non-electrolyte. Now, strong electrolyte and weak electrolyte. Strong electrolytes are substances that ionize or dissociate completely or close to completely. Okay, strong acids, strong bases, and soluble salts. We know all soluble salts will dissociate into ions. Strong acids, strong bases are the ones that ionizes or dissociates 100% or close to 100%. So those are strong electrolytes. Weak electrolytes are the substances that do not ionize or dissociate completely. They do ionize, they do dissociate, but not 100%. Examples will be weak acids and weak bases. Two pictures showing us the difference between a strong electrolyte and a weak electrolyte. A strong electrolyte, the light bulb lit up brightly. Weak electrolyte, the light bulb lit up but pretty dim. Exercise. Identify the following compounds as strong or weak electrolytes or non-electrolytes. Electrolyte-wise, if there's any questions you will see in this class, it's going to be either their definitions or a question like this. Some formulas will be provided and you will be asked to identify if they are strong, weak, or non-electrolytes. How do you do it? Look at the formula, identify if it is a soluble salt, strong acid or base, weak acid and base. Soluble salts, strong acid, strong bases are strong electrolytes. Weak acids, weak bases, weak electrolytes. Molecular compounds other than areneous acid, non-electrolytes. So I will leave this question to you. Pause the video, complete them, and check the answer key later. Here is the answer key. See you next time.